The Fujita and Enhanced Fujita Scales tornadoes are ranked by the damage they cause, not by direct wind measurements. That's because it's nearly impossible to place weather instruments inside the funnel of one of the world's most destructive storms. For decades, scientists relied on the Fujita scale, created in 1971 by meteorologist Dr. Tetsuya Theodore Fujita. His system estimated tornado wind speeds based on damage to buildings and vegetation. In 2007, the United States adopted the Enhanced Fujita Scale, EF scale, which fine-tuned these estimates. Engineers and meteorologists studied hundreds of tornado aftermaths and realized the original Fujita ratings often overestimated wind speeds. The EF scale corrected this, linking specific types of structural damage to more accurate wind ranges. Today, when you hear a tornado described as EF0 through EF5, that rating is based on detailed surveys of destruction after the storm. EF0 tornado, winds 65 to 85 miles per hour, 105 to 137 kilometers per hour. An EF0 tornado is considered weak, but don't let the word weak fool you. Winds at 65 to 85 miles per hour can still cause serious damage. Roof shingles may be torn off, gutters ripped away, and fences blown down. Small trees are often snapped like twigs, while larger ones lose branches. Outdoor furniture, trampolines, and other lightweight objects can become flying projectiles. Although EF0 tornadoes rarely destroy entire houses, they can make life dangerous for anyone caught outside. In rural areas, farmers may lose outbuildings or sheds. On highways, drivers can struggle to keep their vehicles steady in the powerful gusts. Statistically, EF0s make up the majority of tornadoes recorded in North America each year, and while fatalities are rare, they still send people to hospitals with injuries from flying debris. EF1 tornado, winds 86 to 110 miles per hour, 138 to 177 kilometers per hour. A tornado with an EF1 rating is the next degree of intensity, and it is frequently the first level at which the level of destruction becomes significant. Tornadoes with an EF1 classification can reach speeds of up to 110 miles per hour, which is enough to tear off significant portions of roofing from houses, shatter windows, flip mobile homes, and even roll vehicles off highways. In the event that wooden electricity poles break, extensive blackouts could occur. To put this into perspective, a Category 1 hurricane has wind speeds that are comparable to those of a tornado. However, tornadoes are significantly more concentrated, with their fury concentrated into a considerably smaller area. It is for this reason that an EF1, despite being on the weaker side of the scale, is nevertheless capable of wreaking havoc on a small town block or a mobile home park area. If people do not seek appropriate shelter, they are more likely to get injuries, and although deaths are less common, they do occur. EF2 tornado, winds 111 to 135 miles per hour, 178 to 217 kilometers per hour. By the time a tornado reaches EF2 strength, it becomes a serious threat to life and property. Roofs are often ripped completely off well-constructed homes, leaving walls exposed. Large trees can be uprooted and tossed aside. Cars and trucks may be lifted off the ground and thrown, sometimes ending up on top of buildings or wrapped around trees. EF2 tornadoes are also destructive in agricultural areas, flattening barns and silos, ripping irrigation systems apart, and killing livestock caught in the open. Communities hit by EF2 storms often experience widespread damage, with dozens of homes destroyed and infrastructure crippled. One infamous example was the 1997 Gerald, Texas tornado outbreak, where several EF2 and stronger tornadoes caused catastrophic destruction. While EF2s are not the strongest, they represent a tipping point. Survival above ground becomes more difficult, and entire neighborhoods can be left unrecognizable. EF3 tornado, winds 136 to 165 miles per hour, 218 to 266 kilometers per hour. EF3 tornadoes are classified as strong, and their destructive power is shocking. At speeds of up to 165 miles per hour, an EF3 can blow apart large sections of well-built homes, flip trains off tracks, and snap steel-framed structures. Forests hit by an EF3 are often left looking like they were flattened by dynamite, with thousands of trees splintered and stripped bare. Vehicles don't just roll, they're hurled through the air, sometimes for hundreds of feet. Concrete block structures such as schools or commercial buildings may collapse under the stress. Entire neighborhoods can be reduced to rubble, and recovery often takes years. One tragic example is the 2013 El Reno, Oklahoma tornado, rated EF3 at its widest point. It was nearly 2.6 miles wide, the largest tornado ever recorded. Though it didn't strike the heart of a city, it claimed the lives of experienced storm chasers and showed the terrifying reach of a storm in this category. EF4 tornado, winds 166 to 200 miles per hour, 267 to 320 kilometers per hour. EF4 tornadoes are rare but among the most catastrophic events on Earth. With winds up to 200 miles per hour, they can level entire houses, tear asphalt from roads, and toss vehicles like missiles. Even reinforced concrete buildings may sustain heavy damage, and well-built homes are often swept clean from their foundations. In an EF4's path, survivability without underground shelter is slim. Communities hit by EF4 storms often resemble war zones. Hospitals, schools, and infrastructure are destroyed, leaving survivors cut off from emergency aid. The 2013 Moore, Oklahoma tornado is a haunting example. Rated EF5 at peak, but with EF4 level winds across much of its path, it killed 24 people and injured over 200. The tornado obliterated 2 schools and entire neighborhoods, leaving behind a scar that took years to heal. EF5 tornado, winds over 200 miles per hour, 322 plus kilometers per hour. At the top of the scale sits the EF5, nature's most violent windstorm. EF5 tornadoes are extremely rare, but when they strike, the devastation is almost beyond comprehension. Winds exceed 200 miles per hour, with some estimates reaching over 300 miles per hour in extreme cases. At this level, the concept of damage changes. Homes aren't just destroyed, they're obliterated with debris scattered miles away. Entire neighborhoods vanish, leaving bare slabs where houses once stood. Trees are debarked, cars are thrown thousands of feet, and even heavy machinery like tractors or buses can be flipped and hurled. Asphalt can be peeled off highways, and high-rise buildings may sustain severe structural failure. One of the deadliest modern examples was the 2011 Joplin, Missouri tornado, an EF5 that killed 158 people and injured more than 1,000. The storm shredded hospitals, flattened businesses, and left the city looking like it had been bombed. Survivability above ground is nearly impossible without reinforced storm shelters. Why tornado categories matter. The Enhanced Fujita Scale isn't just a scientific tool, it's a public safety lifeline. By linking wind speeds to observable damage, meteorologists can issue warnings and emergency managers can prepare communities. Building codes in tornado-prone regions, such as parts of the U.S. Midwest and South, often rely on EF scale data to design safer structures. More importantly, when people hear EF4 or EF5 on the news, they immediately understand the level of threat. This shared language helps save lives by emphasizing urgency. Even though most tornadoes are EF0s or EF1s, the potential for an EF4 or EF5 means that every tornado warning should be taken seriously. Thanks for watching. If you learned something new about tornadoes today, don't forget to like, share, and subscribe for more science and history explained simply. And remember, no matter the category, always respect the storm.